Solution of nonlinear equation. This is the topic under consideration of the lecture today. Nonlinear equations are what? Suppose we have any equation like a quadratic equation. A general quadratic equation is ax square plus bx plus c. This is the simplest nonlinear equation. Simplest nonlinear. And we may have an advanced equation like as I told you, the function of the normal probability distribution 1 upon under the root 2 pi sigma e raised to the power minus half x minus mu upon sigma whole square in the limit minus infinity to plus infinity. And the second thing, we may have the two parameters in this model, which is mu, which is greater than 0. No, mu may be from infinity, minus infinity to plus infinity, but the variance is from greater than equal to 0, because variance can never be negative. So this is the function of normal probability model. If we need to solve this type of model, that is also a nonlinear, and the simplest nonlinear is the standard quadratic equation. So what is the meaning of solution of a nonlinear equation? Solution of nonlinear equation means if I equate the quadratic function to 0, this becomes a nonlinear equation. And solution means we have to obtain x-intercepts. We have to obtain x-intercepts. These x-intercepts are the solution. So what is the objective of the entire chapter? The objective of the entire chapter is to obtain the x-intercepts. X-intercepts are also known as the roots of the function. This is also called zeros of a function. Zeros of a function. Now the roots finding problem. That is the objective and the agenda of this lecture. Initially the definition of root finding, then we have the classification of methods, analytical solution, the graphical method, the numerical method. So our objective and our agenda is to study the numerical procedures. This is the agenda of my lecture today. Bracketing method, open method, these are the two methods, and then converge notations. So this is the entire agenda of the lecture that we are discussing today and tomorrow. Roots finding. Roots finding, the many problems in science and engineering are expressed as continuous function. I told you what is the meaning of continuous function. Means there is no break within the limit of the function. As this is the graph of the normal probability distribution, there is no break in between that. This is the parabola or a simple quadratic function. There is no break. If there is no break, we can call the function as continuous. Given a continuous function, finding the value of r such that f of r is equal to 0, or we can call it as a y is equal to 0. So you have to find all values of x for which the function is 0. This is known as x-intercepts of the functions. X-intercepts of the function can be determined by a simple problem we have here. Suppose a fourth degree equation is there. On the left side, we have x4 minus 3x cubed minus 7x squared plus 15x is equal to minus 18. Take minus 18 to the right side and try to factorize it. So it will have the four factors. One of them is x plus 2, other of them is x plus 1, and x minus 3 whole square. It means we have two distinct roots, minus 2 and minus 1. These roots are known as the distinct root. Distinct root are those roots which have the separate values. And we have the two repeated roots, 3. 3 will be a root 2 times. So 3 is the root which occurs 2 times, and minus 1 and minus 2, these are the two distinct roots. So one repeated root and two distinct roots, that is the solution. That is, we did this by the process of analytic solution. This type of solution is known as analytic solution. In the analytic solution, we have a predefined formula and the predefined procedure is specific for solving the situation. Another name of the finding the roots is finding the zeros. So zeros of the function can also be used for finding the roots. So if we have a function which has two roots, x minus 2 and x minus 3, the 2 and 3 are the zeros of this function because fx is equal to 0. When you put fx is equal to 0, it means x minus 2 times x minus 3 is equal to 0. And if either x minus 2 is 0 or x minus 3 is 0, so this will becomes 3 and this will becomes 2. These are the two roots, or the two zeros, or the two y-intercepts. Because why these are the y-intercepts? Because no, not y-intercept, x-intercept, I'm sorry. So these are the two x-intercepts because x-axis will be cut down at these 2 points. The function cut at the x-axis at the 2 points. What is the graphical interpretation of these zeros? The real zeros of a function fx are the values of x at which the graph, the function crosses or touches the x-axis. So you can see that by this graph is passing the x-axis at the 3 distinct points. So we may call it as this function, whatever the equation of the function we have, this function is a cubic function. Means it has the third degree. The reason is because it has the 3 x-intercepts. So as many x-intercepts there are, is the degree of the given function. Now this function has 2 x-intercepts. The first x-intercept is this, and another x-intercept is this. So these are the 2 x-intercepts of the function. And the function is quite simple, x squared minus x minus 2. You can factorize it with a simple method. One of them is x plus 1 and other of them is x minus 2. The x-intercepts are the zeros. Multiple zeros, we have the 2 zeros at one point. This is, we call it as the repeated roots. Repeated roots. Repeated roots are those roots at which the function has a second degree, but this point is a single point of the function. Origin, this is the origin at which we have the two solutions. One is x minus 1, x is equal to 1, and other is also the x is equal to 1. So these are the two roots. So actually these are not two distinct roots. This is a root which is repeated twice. It has 3 zeros. X cube, if the graph of x cube, you are observing the graph of x cube, it passes through the origin, and you can see that this cubic function has 3 zeros at x is equal to 0. Now, nth order polynomial has exactly n zeros. Nth order polynomial can have n zeros. Out of these n zeros, some of the zeros are real, but maybe the sum are complex. What are the complex zeros? Imaginary numbers, because all of you are familiar with the two types of numbers, real numbers and imaginary numbers. Real numbers and imaginary numbers, these are the two types of zeros, and we have to find these zeros. If nth degree polynomial you have, you can have n, total number of zeros will be n. Out of these n zeros, the sum of the roots are real and the sum of the roots are not real. If the polynomial is of order n, then it has at least one real zero. Meaning what? Meaning that odd power is, suppose we have a third degree equation, then we may have all the 3 real zeros, we may have 1 real zero, then 2 non-real zero will be there. So in an odd function, if there are some zeros which are imaginary, then they will be in a pair format. Why they will be in a pair format? Because of plus minus sign in the radical. Plus minus sign in the radical we may have. So in an odd function, we may have the real zeros which are in a pair form. Roots of the equation. Roots of the equation, we have another example of the root of equation. You can see here the same fourth degree equation as I described earlier. So I'm not discussing this slide again because it is already discussed. Solution methods, several ways to solve the nonlinear equation. Let's take graphical, numerical, open bracketing. इस पे discussion हो चुका है. Now this is the simplest equation, and the analytic solution is shown here, but no analytic solution exists for this. If we want to solve this equation, which is x minus e raised to the power x is equal to, so we may consider the two functions. One function is y is equal to x, and second function is y is equal to e raised to the power minus x. If I plot the function y is equal to x, then the graph will be like this. Y is equal to x is a line at 45 degrees. Whenever I will draw a function of exponential e raised to the power minus x, it will be a function like this. Is the exponentially decline function. There is not possibly passing through the zero. So the function, the point where these two will be intersecting each other will be the solution of this nonlinear equation. So quite simple, but it's a graphical procedure. So in this graphical procedure, what we are observing that the function y is equal to x and the function e raised to the power minus x, these two functions are plotted. The intersection of these two will give us a solution. So we are not getting an exact point on the graph, but we are getting a point which is highlighted, and the range is from 0 to 1. So we can say that there is a root exists between 0 and 1. And that root we can search with the help of open method or by the bracketing method. This procedure is called finding the roots or approximating the root by the help of graph. But in this chapter, our discussion will be about the bisection method and Newton's method and secant method. There are the other further methods available in the literature: false position method, Muller's method, Bairstow methods, and the fixed point iteration method. But we are going to consider only the first three procedures here in this presentation. Bracketing method, as I told you, we have to guess an interval. So what is needed? A guess is needed. And we have to search the root by considering the midpoint. The interval is given. In the interval, we have to obtain the middle value of the interval and checking whether the root exists within the interval or not. There is a criteria by which we can check whether the root exists within the interval or not. So there is a possibility that the interval that we suggest will not contain the root. If the root will not be there, then we have to select another interval. Bisection method and false position method, these are the two bracketing methods. But first one will be considered in this presentation. Open method, we have one initial point as a guess, and we will search the problem and we will search the root with the help of one point. So in bracketing method, we will search within a bracket, and in the open method, we will search with the help of a point, a single point. So that is the difference between the two. If the point that we select, the error becoming smaller, then we can say that the series is converges and we may get a solution, or we may get a root. If the error is increasing, we can say that the series is diverges and we are not getting the solution. So that is the criteria of whether the root exists or root does not exist. If the error is reducing, means the series is converges, and there is a possibility that we have a root between that. Bisection method. For bisection method, we need 3 items. What 3 items are needed? We need 2 items. One is the function for which we want to solve or want to find the root. The second thing is the interval. We need an interval within which we are expecting the root will be there. But there is a possibility that because this interval is a guess, so there is a possibility that root will not be exist. So there is a test and a criteria whether the root will exist within the interval or not. The bisection method is one of the simplest methods to find the zeros of a nonlinear function. It is also known as interval halving method. We have to halve the interval. Bisection, as the name is indicating, bi means two parts to be considered. The method is systematically reduces the interval. It does this by dividing the interval into the 2 equal parts. Now, we need what? fx. Fx should be there. And define on interval AB, the limit of the function will also be there. The function exists within A and B. The intermediate value theorem says what? If the FA and FB, FA is what? FA is the height at point A, or the value of the function at point A, and FB is the value of the function at point B, then the root will exist if the product is negative. If the product is negative, we can say that at least one root exists within that. Why we are saying that at least one root exists within that? The reason is there is a possibility that there are more than one root exists within this interval. It's like this. Suppose this is the function and this is our x-axis. This is the point A. This is the point B. So you can see that FA is positive because it has a upper y-axis, and FB is negative because it has a lower y-axis. So the product FA times FB is negative. So we can say that the root exists within A and B, but there are the three roots exist within A and B. One of them is this, second is this, and the third is this. So that is why we are saying that at least one root exists within the interval if this condition is fulfilled. What that condition is, the product of the values of the function at the 2 points is smaller than 0, not 2. It is smaller than 0. If the product is 0, means if the product is, or we can, other way around, we can say that if the sign is different, it is positive because it is on the upper y-axis. It is negative, the sign is opposite. If the sign is opposite, means the product is 0, is less than 0. The root will exist there. At least one root will exist there. So this is the criteria. So in this case, we have FA and FB, but multiple values are there. But both are positive. Both are positive, but roots exist. So if F and FB have same sign, the function may have an even number of real zeros or the no real zero in the interval. We have 4 points here. If the both are, so there is a possibility. Another situation is if FA and FB both have the same size, then no zero exists because it doesn't touch the x-axis. There is no zero exist. And here is the example where we have multiple zeros which are even in number within that too. Another example of this is suppose we have a simple parabola, and on x-axis we have FA here. This is FA. This is FB. The sign is same because it is positive. This is also positive. The 2 points or the 2 roots exist within the given interval. So we can see that if the signs are same, then there is a possibility that even number of roots will occur or root will not be occur in the interval. If FA and FB have the different sign, then the function has at least one real zero. Bisection method can be used to find the one of the zeros among them. It will give us a one value of the root. If the function is continuous and the interval is given, then FA and FB have a different sign. Bisection method obtain a new interval by halving the previous interval. So if A and B are given, so we have to determine another point C by the midpoint method, A plus B divided by 2. So now we have 3 points. One is A, other is B, which is given as an initial guess. And we have another point C, which is given as a mid value. So now the interval is broken into the two intervals. One interval is from A up to C. The second interval is from C up to B. these are the two intervals. Now either root will be in this interval or it will be in this interval. So we have to check the product again at FA and FC. If the product of FA and FC is negative, means the root is in this interval. If the product of FC and FB is negative, means the root is in this interval. So this is the technique which we have to follow till the either the number of iterations are to be completed or the amount of error is reduced up to the certain amount. The assumptions are what? A and B are given, the function is continuous, FA and FB have opposite sign. These assumptions ensure that existence of at least one root in the interval, and the bisection method can be used. So these are the assumptions. If these assumptions are fulfilled, then we can find a root. This is the algorithm. Fx is continuous, Fa times Fb is less than 0, then compute the mid-value C, evaluate the function at C. If Fa times Fc is less than 0, then interval will be the A and C. If Fa and Fc will be greater than 0, then, so these are not the two if, that is one if with the else. Then CB will be the interval where we have to search, and this algorithm will be repeated till we have a certain number of iterations, or we have a amount of error reduced to up to a certain limit. This is the procedure. Now we can see that bisection method at A and B naught. If we are computing the midpoint, so A naught, A1 and B naught. Now A naught, the function is positive because it is on the upper half of the x-axis. At A1, the function is positive. The product of these two will be positive, means that this interval will not have a root, but here the function is positive, and at B naught, the function is negative. The product is negative. We can see that there is a root exists. Now we have to find out the another point A2 by the midpoint. This is the midpoint of A1 and B naught. So A2 and B naught. Now the next midpoint will be here, the next midpoint, and so on. So at every midpoint, we are becoming closer and closer to the root. So this is the procedure of bisection method. You can see we are having the interval. In this interval, we have the two positive sign, means y-axis is positive, y-axis is positive. But here we have a negative y-axis, so which is down. And in this interval, we have the both negative. This interval will have the root. Here we can see that the both intervals are positive. So the root will be in this interval, and so on. This procedure will be continued. This is the flow chart of bisection method. What is to be given? A and B, means an interval is given. And what E is a certain amount of error, up to, suppose we are saying that 10 raised to the power minus 5. This is the value of error that we have fixed. If error becomes smaller than this, then loop will be terminated, otherwise the loop will continue. So these are the three values, that is, these are the inputs of this algorithm, which is represented with this green rectangle. Then you calculate FA and FB. And the value of FA is represented by U, and the value of FB is represented by V. Now, midpoint is to be calculated, A plus B by 2. This midpoint, A plus B by 2, give us a second point, which is C. Now the interval is broken into A, B, and C. And we have calculated the function value at C, which is FC. FC is W. So now we have the three function values. U is the function value, V is the function value, and W is the function value, and these are the value of Y coordinates. And we have X coordinates too. The first X coordinate is A, and the Y coordinate is the U. The second x coordinate is b and the function values, and the third coordinate is c. So these are the x values and these are the y values on the y-axis. So now the product is seen. If u into v is less than 0, if u into v is less than 0, means the root exists within a and b. So we have to use this path. And if u into v is greater than 0, as I told you, there is only one if, other is else, then we have this path. So what this is indicating that if a and b, the product of u and w, sorry, if the product of u and w is negative, so we have to switch one point, which is point B. Point B is replaced by C. The value of C will be stored in B, and so on. Otherwise, the value of A will be stored in C. So either one point is to be used. Either C will be updated by B or the C will be updated by A. So this is the technique which we did. And then we have to calculate the next point. If the next calculated point is smaller than E, which is calculated in the error, distance is divided by 2. B minus A is what? B minus A is the distance. Distance is divided by 2. It is error. Then we have to stop. Otherwise, if the error is not as smaller as it is specified in the problem, so we have to go to the next point, which is here. So this algorithm is to be applied on this problem. Here, a cubic equation is given, and we have to find out in the interval 0 and 2. We have to calculate what? We have to calculate f of 0. Then we have to calculate f of 2 and check the sign. F of 0 will be 1, because if we put 0 here, it is 0. If we put 0 here, it is 0. The only value is 1. Now we have to calculate f of 2. F of 2 can be calculated as 2 cube minus 3 times 2 plus 1. So 2 cube is 8 minus 3 into 2 is 6 plus 1. 8 minus 6 is plus 2 and 1 is plus 1. So it is 3. So it is positive, FA is positive, FB is positive. So we can say that the bisection method does not contains the root in between 0 and 2. This is the check that we have to apply for a bisection method. So you can see that the two function values are positive in the interval. So we can say that the root will not be. So one point is 1 and the other point is 3, product is 3, 3 is greater than 0. Assumptions are not satisfied, bisection cannot be used. Another example. In this example, we have to check the same example we have, but the interval is changed. Instead of interval given in the previous slide, we have another interval which is 0 and 1. So we have to calculate f0 is 1. Because when we put 0, then it will be 1. Then we have to calculate f1. f1 is what? 1 cube is 1, minus 3 times 1 is 3, plus 1, it is equal to minus 1. Now f0 multiplied by f1 is less than 0. Means 1 multiplied by minus 1 is less than 0. We can say that root exists. Yes, the root exists within that. If the root exists within that, we can determine the root by taking the midpoint. The midpoint of 0 and 1 is what? Midpoint of 0 and 1 is 0, 0.5, and 1. So now we have the two intervals. One is from 0 to 0.5, and another interval we have from 0.5 to 1. Either the root will exist within this interval or within this interval, then we can check. We have to calculate f of 0.5. F of 0.5 is how much? F of 0.5 is 0.5 cube minus 3 into 0.5 plus 1. So 0.5 cube means 1 upon 8 minus 3 upon 2 plus 1. What about 1 upon 8? 3 upon 2 becomes 1.5. I think it is 0.2. So I think it is negative. It is negative in sign. So if it is negative and this is positive, f0 is positive, so means the root will exist within 0 and 0.5, because here we have the function positive. At 0.5 we have the function negative. The root will exist between 0 and 0.5. But root will be, both signs are same. We have a negative sign at 1. We have a negative sign at 0.5. The root will not exist between 0.5 and 1. So this is the technique of determining, firstly checking whether the root exists within that or not. The second thing is, if the root exists, then we have to halve the interval, and the interval is broken into the two segments, and we have to check for each segment whether the root exists or not exists. So that is the procedure that we have to follow for solving this problem completely. And this problem is the first problem we are going to implement by bisection method. So you can see here, the sign is negative, assumption satisfied, bisection can be used. Bisection method contain an interval. Now the next thing is what? Estimates of 0, and then the next value is calculated and error is computed by this formula. B minus A divided by 2 means difference of the interval divided by 2. That is the error we are computing. If the error is smaller than a specified number, then we will stop the iteration. The stopping criteria. The stopping criteria, we have the two stopping criteria. As I told you earlier, we can have the fixed number of iterations. Suppose we are saying that we will repeat the procedure 5 times or 10 times, or we have absolute error less than a specified value. Either we can fix a stopping criteria related with the error, or it will be related with the number of iterations. Cos x. We have to find out the root of the function x is y is equal to cos x. X is equal to cos x. This function in the interval 0 and 0.9. So we have to check the function, how many iterations are needed, whether assumptions are satisfied or not, how to compute the new estimate. These are the questions. Now I am going to skip this slide because it is the algorithm, as I told you and explained the algorithm earlier. So I'm just skipping it. So this is the graph, and every time we are computing function values and within the interval, and check whether the sign of the interval, sign of the function is negative. So here the sign is negative, here the sign is positive. The root will exist within the interval, the meta value is calculated and error is calculated, and so on. The procedure is continued. Now, initial interval, 5 iterations. This is a summary of the problem. And we can see that the root exists, but the estimate of the root is 0.7 something. This is the estimate of the root. And we can check the error because we can have the exact solution of the problem, real solution of the problem, and we can have the approximate solution of the problem. So we can check error as well. This is the MATLAB code of the bisection method. It's quite simple, and in this problem, we are just explaining what we are explaining. The A is 0.5 and B is 0.9, and function A minus cos A, and the B value is the B minus cos B, and for I is equal to 1 to 5, the C is computed, and FC is calculated, the product is negative, then the values are updated, otherwise the next earlier and the procedure is continued. Is a iteration-based code. Is not an error-based code, is a iteration-based code. You can see that the root is there. Every time, this is the root. Best possible value is this 0.725, the C point. Initial C point was this 0.7, then it is 0.8, then it is 0.75, then it is 0.725. So this is the approximate value that we can use up to the few iterations, 5 iterations. Now we have to implement the procedure manually here with the help of this equation. In the interval 0 and 1, as I told you, the root exists within this interval, product is negative, so we are going to find the iterations. What are the next iterations? 1 and 0, 0 and 1, sorry. The midpoint is 0.5, FC is calculated, and error is calculated. Now we can see that the next value is 0 and 0.5. We started by 0 and 1, and the root exists within 0 and 0.5. The new value is calculated by C. Now we have to check F0 and F0.5. If it is negative, it means the root exists within this interval, and the value is 0.25. And so on. Next time, the value of C is 0.375. Next time, the value is 0.3125, 0.345, and so on. Up to the 5 iterations, the value is 0.345, and error is becoming smaller. It was 0.5, it was 0.25, it is 0.125. Every time the error is reducing. So if error are reducing means we are going to converge the series, and if error are increasing, that is an indication that we have a divergence case and root will not be exist. So this is the concluding slide of bisection method. The advantages are what? It is simple to apply the function. One function evaluation per iteration. The size of the interval containing the 0 is reduced 50%. But it has a drawback. What the drawback it has? Convergence will be slow. I am giving you the one example of why this is. Suppose I have an interval. The function is this. This is the function. This is the function, and I am using this point A. I'm using this point B. The root is very near to the B. The graph is showing that the root is very near to the B. But we are taking a very big interval from A to B. So every time we are getting the midpoint, then the procedure becomes slow. Instead of bisection, if I am using another procedure, Newton's method, that will be and with the initial guess of this, so we will get a quite better result in few iterations. So bisection method will give the number of iterations and higher number of iterations, and in contrast to the Newton's method. Newton's method will be described in the next video. So I am stopping the video here.